We're looking at factors, factors of whole numbers specifically. And so if you want to look and if you want to figure out what the factors of a number like 42 are, one of the ways to go about it, first off, factors are numbers that divide evenly into 42. So 1, 2, 3, those are all factors of 42 because when we try to divide 42 by those numbers, it comes out evenly. Let me pull out a calculator here. So you can see if I was to take 42 divided by 1, it works, of course. 42 divided by 2 works. 42 divided by 3, that works as well. These are factors of 42. But when we get to 42 divided by 4, you can see that one doesn't work. 4 is not a factor of 42. And so if we're trying to get a list of all the factors of 42, we could go through all the numbers between 1 and 42 and start listing, check each and every single one of them. But it turns out there's a better way. If I'm trying to find the factors of 42, I could start off by saying, well, 1 times 42 is equal to 42. This doesn't just tell me that 1 is a factor, it also tells me that 42 is a factor. Then 2 was a factor of 42, but not just 2, 21 is also, because 42 was 2 times 21. 3 is also a factor of 42 because 14 times 3, and also 14 is a factor. And the way I'm doing this is hopefully a little bit suggestive. This is kind of going to be a complete list fairly quickly. We already checked 4. 5 doesn't go into it. We could check 6. 42 divided by 6, and that works. We get a 6, and 6 times 7 is equal to 42. At this point, so I've checked the numbers I've actually checked here. 1, 2, 3, 4, 5, 6. The next number I would check would be 7. 7 is already on the list, though. And once I get to a point where I've arrived at a number that I've already gotten, as long as I'm being complete here, I don't skip anything, then this 7 has already been gotten, which means actually at this point I can conclude that my list is complete. So all the factors of 42 are here. 1, 2, 3, 4, 6, 7, 14, 21, and 42. You may be thinking about, well, what happens if there's something between 21 and 42? Well, in order for there to be something between 21 and 42, to be a factor of 42, we would actually have to have something corresponding over here, something between 1 and 2 that would work. We already know that there's no whole numbers between 1 and 2. So that's how I know that there's no factors between 21 and 42. Similarly, between 14 and 12. But then the question, okay, what about between 7 and 14? Well, that, again, you look to see 7 and 14. If there's something between 7 and 14, there would have to be another number between 3 and 6. But we've already checked all the numbers between 3 and 6. 4 didn't work, and 5 didn't work. So that's how we know we have a complete list here. Now, for something like 93, this is a little bit bigger number. Well, 1 and 93 works. 2 doesn't go into it. 3 and 31 work. But then, there's a bunch of numbers between 3 and 31, and I could go through there and check them all. You'll notice that even numbers are never going to be factors of 93 because, well, 93 is not even. So you can kind of, let's say an even number was a factor of 93, then 6 times blank equals 93. Well, 2 is actually a factor of this, which means 2 would actually have to be a factor over there as well. In any case, there are tricks you can use to try to cut this down, but for our purposes right now, we would actually need to go through and check all the numbers up to 31 here. So 93 divided by 5, I'm just going to skip over even numbers because of that argument I just made. 93 divided by 7 doesn't work, 93 divided by 9 doesn't work, and so on. This is pretty quickly a tedious process. So I'm just going to skip it and say, okay, well, you know what, there's got to be a better way. This is actually a complete list, but let's think about what a better way would be there. To achieve that, let's look at this next one first. So looking at all the factors of 7, some of you might recognize 7 as what's called a prime number. If we check 2, 3, 4, 5, and 6, none of those go into 7. And 7 is a prime number. One way of saying that, the actual one definition of a prime number is that only has, or that has exactly two factors. Another way is to say that it can't be broken as a product of two lesser whole numbers. So, like 42 is not prime because we can break it down as 2 times 21. Both of those are less than 42, and it's a product of those two numbers. We can't do the same thing for 7 because the only way we can write that as a product is 1 times 7, or at least a product of whole numbers. The only way would be 1 times 7, and of course 7 is not less than 7, so that wouldn't work. So I say a prime has exactly two factors. That's how we're going to, that's the definition I tend to use. And so we can get a list of the first few prime numbers. 2 is the first prime number. 1 is kind of in its own list. We don't call 1 a prime number, so I'm going to leave it off rather. 3 is prime. 5, 7, 11, 13, 17, and 19. Those are the first few prime numbers. If you're interested in having a longer list than that, you can look it up on the internet. This is generally long enough for any of our purposes.